Okay, so in just terms of our function notation and thinking about things like domains and restrictions of functions, that sort of thing. So we've got here a rule where the volume of an object, the volume of a sphere in fact, is given by 4/3 pi r cubed. Okay, so all we're saying here is we've got some function in terms of r, so the volume V is given in terms of r, all right? So what's a practical domain for this function? Well, let's think about it. What does r measure? R is measuring a radius. So really r has to be strictly greater than 0, because if you have a 0 radius, well, you have no shape. So there's my restriction. So my practical domain would be from 0 to infinity. To work out V of 10, well, from our function knowledge now, that means we just substitute 10 in. So 4/3 times pi times 1000. So what if we just leave it as 4000 pi on 3? Okay, we could then use a calculator to get an approximate, but I think that's reasonable there. That's not a bad place to leave it. All right? Okay. Let's have a think about this. Inverse functions, all right? It's a fairly important topic, this one. Inverse functions, it's a process by which we swap our x and y values to come up with a new function. Inverse functions, we can find the rule for any inverse function, but they only exist if our function is one-to-one. So remember a one-to-one function? A one-to-one function is any function that if we, draw a line, a vertical line crosses once, a horizontal line crosses once. So that's my one-to-one function. So to have an inverse, our function has to be one-to-one, all right? And a couple of interesting things here. So the key thing, if the function is one-to-one, then an inverse function exists, and we use the notation F inverse. Okay, so F inverse is our inverse function. To find it, we interchange the x and y values and then make y the subject. All right, which means if you think about that, if we're swapping our x and y values, that means, so it's not written here just yet. So if we think about swapping our x and y values, so our domain of f are all the x, the range of f is all the y. Now, for my inverse function, the x values have been swapped with the y values, so for the domain of the f inverse is the y values, and the range of the inverse function are the original x values. So my domain and range swap, basically, for my inverse function. So let's have a look at the graph sketch. Let's work through an example and see how we go with it. So f of x equals 2x plus 5. So let's x-intercept, I'll put y equal to 0. So 0 is equal to 2x plus 5. X is equal to -5 on 2. Y-intercept, I put x equal to 0, and we get y is equal to 5. So I get -5 on 2, +5, and there's my line, okay? The domain of f is r, the range of f is also equal to r. Is f of x a one-to-one function? Well, let's do a vertical line. Crosses once, yes. A horizontal line anywhere, crosses once, so yes. Find the inverse. So to find the inverse, I swap x and y values. So I literally do that. So that means normally y is equal to 2x plus 5. So I swap it. X is equal to 2y plus 5. So now I transpose everything. So I get x minus 5 is equal to 2y, divide by 2, y is equal to a half of x minus 5, or if you like, x minus 5 on 2. Now, instead of writing y equals, which is what I've got here, okay, I have to change that to you look at the function, there's no y in it, so I have to write it as f inverse. The inverse function of x is equal to x minus 5 on 2. So it says to sketch the graph of y equals f of x on the same set of axes as f and state the domain and range of the inverse. So first things first, I might try and rub out that green line that we put for the origin. So that point there was what? Negative 5 on 2. And that point there is 5. So now let's sketch our inverse function. I'll do that in yellow. So come over here, let's put y equals x minus 5 on 2. So if I put x equal to 0, y is equal to negative 5 on 2. And if I put y equal to 0, 2 comes across to give me 0, x is equal to 5. What do we notice about those intercepts? X is equal to 5 is there. Y is equal to negative 5 on 2, which is say there. And there's my other graph. Notice y-intercept of 5 becomes an x-intercept of 5 for the inverse. A y-intercept of negative 5 on 2 is the x-intercept of negative 5 on 2 for the original. So everything swaps, the x and y values swap, and that's always the case. For the domain and range of my inverse, the domain of f inverse is equal to the range of f, which is still R, and the range of f inverse is equal to the domain of f, which is also R. Okay, so that really important concept. Inverse function has to be one-to-one function, all right? We interchange the x and y to find it, and then the key things are the domain of one becomes the range of the other and vice versa, all right? I reckon that's it for the question. Done. So let's just reiterate those key features. Only exists if the function is one-to-one. So we've got to be clear about a one-to-one function. And sometimes we get asked to change it. The domain of my inverse is the range of the original. The range of the inverse is the domain of the original. All right? We talk about the graph of the inverse function is a reflection of the graph of the original function about the line y equals x. Okay? So what that means is that if you go back to look at our original the graph that we drew earlier, one of the lines was like that, the other line was a bit like that, and if I was to draw the line y equals x, which is there, we're saying that they're a mirror image of each other. If I flip these about that line, they're a reflection. Okay, so that's what that means. The point of intersection, if I extend this line out, the point of intersection, if we do our graphs accurately, is always on the line y equals x. That's what that one says. All right? So they're important, but the key ones here for us are those top three. So let's just do this last part. Find the inverse function for that graph there between x minus 1 squared plus 4, so the domain and range of the inverse. All right. So first things first, let's sketch our original graph. It's a parabola, turning point at 1, positive 4, which is about there. But the domain is only from 1 to infinity, so it's only that section of my graph. Okay? Notice now, with only that section, it's a one-to-one function. All right? So, let's find my inverse function. So what does that mean? Let's write x is equal to y minus 1 all squared plus 4. So I've swapped x and y. Take 4 across. Y minus 1 all squared. Take a square root sign. I get plus or minus. Y minus 1. So y is equal to 1 plus or minus the square root of x minus 4. So that means I'm just going to run out of room here. The inverse function is 1 plus or minus the square root of x minus 4. Before we sketch our graph, we've got to make a decision about this plus or minus. All right, so let's talk about our domain of ranges. So the domain of my original function I've been given as 1 to infinity. The range of my original function is, what was that point? That point was 1, 4, is from 4 to infinity. So that means the domain of the inverse function is from 4 to infinity, and the range of the inverse function is from 1 to infinity. Now, because our range is positive numbers, that means that negative sign can go. So let's put my final answer, f inverse of x is the square root of x minus 4 plus 1. Think about the domain. It's from positive 4, which makes sense. Positive 4 onwards, which give me the graph that I need, or the positive square root. All right. So what does this graph do? It shifts across 4 units and up 1. Across 4 units and up 1 is there. And it's in yellow. So let's do our graph like that. So this is the point 4, 1. Think about this point here. That's the point 1, 4. Notice they've swapped. If I draw the line y equals x, okay, they're a reflection about that line. All right. So look, it's a really important concept, our inverse functions. Take your time, practice it over the weekend, and we'll see how we go.